black holes could actually be involved in creating superheavy elements.
That's a fascinating question.
Right.
It really is.
Like, we always hear about black holes as these cosmic vacuum cleaners, just sucking up everything around them.
Yeah,
But could they also be building something?
that's what we're going to find out.
Okay, so let's break this down.
Okay.
If we want to know if black holes can create superheavy elements,
Uh-huh.
don't we have to first understand how superheavy elements are made?
Absolutely. So how are these superheavy elements formed? Well, the current scientific consensus is that they're most likely forged in these extremely energetic events like supernovae.
Those are the explosions when massive stars die, right?
Exactly. Or they might be created in collisions between neutron stars.
Which are like some of the densest objects in the universe.
They are incredibly dense.
So we're talking about cosmic fireworks when these elements are created.
Yeah.
But then where do black holes fit into all of this?
Well, that's where things get interesting. Black holes are powerful objects, no doubt.
Yeah.
But the conditions around them?
Especially near the event horizon.
Yes. Especially near the event horizon, it's just not the right environment for the processes that need to happen to make superheavy elements through nuclear fusion.
So even though black holes have this intense gravity, it's not like their kitchen's cooking up elements.
It's actually the opposite.
Really?
Yeah. The gravity near a black hole, it creates chaos.
Oh, wow.
And disruption. It's not a stable place for these delicate reactions to happen. We're talking about tidal forces that could rip apart atoms.
I see.
And just constant bombardment from radiation and particles.
So it's not a place where elements can form?
Right.
Okay, so no black hole element factories.
Not likely.
That's too bad.
But I gotta say, the physics of what happens near a black hole is still mind-blowing.
Yeah, it really is. And speaking of which, you mentioned tidal forces.
Yes.
And how they get more extreme the closer you get to a black hole.
Exactly.
What would it be like to actually experience those tidal forces?
Well, to give you an idea, imagine you're falling feet first towards a black hole.
Okay, I'm imagining it.
The pull of gravity on your feet,
Yeah.
it would be so much stronger than the pull on your head.
Okay, I'm starting to get a picture, and it's not pretty.
Yeah, it's not a pretty picture.
But what about those outer edges of a black hole that we hear about?
Uh-huh.
Is there a zone where maybe the gravity is strong enough to do something interesting but not instantly spaghettify you?
That's a great question, and it gets to the heart of how gravity behaves around these objects.
Okay.
Even at those outer edges, you're still in free fall.
Oh, wow.
You're constantly being pulled towards that singularity in the center.
There's no escape.
Once you're in the black hole's grasp, there's no escaping that pull.
So there's no real safe zone?
Nope.
I guess that makes sense, but it's weird to think of gravity that way.
It is. It challenges our usual understanding of gravity as something you can stand on or push against.
Yeah. Like, I usually think of gravity as the reason I'm stuck to the Earth.
Right, but with black holes, it's different.
I see.
It's not just about standing on something, it's about the curvature of space-time itself.
Okay, I need a minute to process that. But let's go back to black holes, maybe doing something interesting.
Okay.
Even if it's not making super heavy elements.
Yeah.
You said they grow by pulling in matter.
Yes.
So what happens to all that stuff that gets sucked in?
That's one of the biggest mysteries in physics.
Is it just crushed?
We just don't know what happens inside a black hole, particularly at the singularity.
I see.
Our current understanding of physics just breaks down at that point.
Really? So anything is possible?
There's a lot of room for speculation and some really wild theories.
Okay, now we're talking. Give me those wild theories. What could be happening inside a black hole that we can't even see?
Well, some scientists think that the matter falling into a black hole isn't just crushed.
What else could happen?
It could be transformed into these exotic forms of matter that we've never seen here on Earth.
Like what?
Like things called quark-gluon plasma.
Quark-gluon plasma.
These are states of matter where the very building blocks of protons and neutrons, the quarks and gluons, are no longer bound together.
So like the primordial soup of the universe.
You could think of it that way.
Wow.
Yeah, it's a state of matter that existed in the very early universe, just fractions of a second after the Big Bang.
Wow. So we could have little pieces of the early universe hiding inside black holes?
Some theories suggest that.
That's amazing. But I'm also remembering what our listener was asking about dark matter.
Uh-huh.
Could there be a connection between black holes and this mysterious stuff that makes up so much of the universe?
That's a very insightful connection. And actually, black holes, particularly primordial black holes, are considered one of the possible candidates for dark matter.
Hold on, primordial black holes?
Yeah.
Are those like baby black holes that formed right after the Big Bang?
Exactly. And because they don't emit light, they would be incredibly difficult to detect directly.
So we could have these ancient tiny black holes all over the place.
Yeah.
And we'd never even know it.
That's right.
That's kind of creepy, but also really cool.
It is, but even if they're hard to find, we might be able to detect their influence through their gravity.
Oh, I see. So even if they're invisible, we might be able to see their gravitational fingerprints.
Precisely.
That's amazing. So how do scientists actually do that? How do they find those fingerprints?
Well, one way is by looking at how these primordial black holes might affect the movement of stars and galaxies.
Okay.
If these black holes make up a lot of dark matter, their gravity should be influencing how things move in the universe.
And we can measure that.
And we can measure that.
That's incredible. So black holes are like cosmic detectives, helping us learn about this invisible stuff called dark matter.
Exactly.
I love it. Okay, so we've learned that black holes probably aren't making super heavy elements directly,
Right.
but they might be connected to dark matter.
Potentially.
And they could even be hiding these tiny pockets of the early universe.
Some very interesting possibilities.
This is blowing my mind. Black holes are even weirder and more amazing than I thought.
They really are, and we've only just begun to scratch the surface of what we can learn from them.
This is why I love doing these deep dives. Always learning something new. Okay, so next time we'll continue this deep dive into black holes.
That sounds good.
We'll look at how scientists are searching for those gravitational fingerprints.
Uh-huh.
And we'll explore the different types of black holes out there.
It's going to be fascinating.
I can't wait. Until then, keep those questions coming.
And keep exploring.
See you next time. It's like a cosmic detective story.
Yeah.
Trying to find these clues to track down these black holes, and it's amazing to think they could be all around us.
Mm-hmm.
And we're just starting to figure out what they do in the universe, but how do scientists go about finding these gravitational fingerprints? Like, how do they actually do it?
Well, one of the key techniques is called gravitational lensing.
Gravitational lensing.
So picture this, a distant galaxy or a star is shining its light.
Okay?
And that light travels for billions of years to reach us here on Earth.
Okay.
But if along the way that light passes by a black hole,
Yeah.
the black hole's gravity can bend the path of that light.
Oh, wow. So the black hole acts like a lens.
Exactly, like a giant cosmic lens warping the fabric of space-time and bending the light around it.
So it's like those funhouse mirrors that make your reflection look all distorted.
I like that analogy.
Only it's gravity doing the distorting.
Right.
And it's not our reflection we're seeing, it's light from distant galaxies.
Exactly.
That is so cool. But what about the movements of stars? You mentioned we could see the influence of black holes on their orbits.
Yeah, that's right. Stars that are near a black hole, they don't just move randomly.
Uh-huh.
They're trapped in the black hole's gravity, so they orbit around it.
Oh, I see.
And if we carefully track how these stars move over time,
Yeah.
we can look for any little wobbles or changes in speed.
That might show a black hole is there.
Yeah, it would tell us there's something massive and invisible pulling on them like a black hole.
So it's like watching a cosmic ballet and trying to spot those subtle cues that tell you there's an invisible partner leading the dance.
That's a beautiful way to put it.
But wouldn't you need to make incredibly precise measurements to see those tiny gravitational tugs?
You absolutely would. It requires super sensitive telescopes
Wow.
and painstaking observations over many years.
Oh, wow.
But astronomers have made incredible progress.
Really?
Yeah. In fact, they've used this technique to track stars orbiting the supermassive black hole at the center of our own Milky Way galaxy.
Wait, hold on. A supermassive black hole in our own galaxy.
Yeah.
That's amazing and also terrifying.
It is pretty mind-blowing.
But if it's black, how did they even find it?
By carefully tracking the movements of stars near the galactic center over decades.
Oh, wow. Decades.
Astronomers realized those stars were whipping around something invisible with a tremendous gravitational pull.
And that something had to be a black hole.
The only explanation that fit the observations was a supermassive black hole millions of times more massive than our sun.
Millions of times. That is some serious cosmic power.
Yeah, it's hard to wrap your head around.
It is. But speaking of powerful events, we can't forget about those gravitational waves.
Oh, yeah, those are incredible.
They seem like a much more direct way to detect black hole mergers, right?
They are much more direct. When two black holes spiral in towards each other and collide, they release these incredibly powerful ripples in space-time.
And those are the gravitational waves.
Those are the gravitational waves. And this was predicted by Einstein's theory of general relativity.
Oh, wow.
And these waves, they can travel across vast distances carrying information about those collisions.
So it's like we're listening to the echoes of these cosmic crashes from billions of years ago and billions of light years away.
That's a great way to think about it.
And to detect these waves, they use these incredible instruments like LIGO, right?
Yes, LIGO, the Laser Interferometer Gravitational Wave Observatory.
What an amazing name.
It is a great name. So these observatories use lasers to measure tiny, tiny changes in the distance between mirrors.
And those changes are caused by the gravitational waves.
That's right.
Wow. So we're talking about measuring changes smaller than an atom to detect these waves coming from across the universe.
That's exactly what we're talking about, and it's amazing.
That's incredible science. But I have to ask, with all these amazing new tools, are scientists finding more black holes than they expected?
It's a really exciting time for black hole research.
Yeah?
Every time we find a new black hole, we learn more about them.
What kinds of things are we learning?
Their variety, their origins, the role they play in the universe.
And are there a lot of them?
Some scientists estimate there could be billions of black holes in our galaxy alone, many of them just waiting to be discovered.
Billions. Our galaxy is teeming with black holes.
It really is.
That's incredible. And with new telescopes, like the James Webb Space Telescope,
Uh-huh.
I bet we're going to find so many more in the next few
Oh,
years.
definitely.
But with all this focus on black holes, are we any closer to figuring out dark matter?
Yes. Our listener had some really great questions about those primordial black holes.
Right. Could they be a big part of the dark matter puzzle?
Well, that's what researchers are trying to find out.
How do they do that?
By mapping out where black holes are and learning more about them,
Uh-huh.
we can get a better understanding of how they contribute to the overall gravity of the universe.
Okay.
And that helps us refine our ideas about dark matter and narrow down the possibilities.
So black holes are giving us clues about this invisible stuff that's holding galaxies together.
They are.
It's fascinating to think that something so elusive could be connected to these huge objects. But I also keep thinking about that exotic matter that might form inside black holes.
Yeah.
Could we ever actually study that directly?
Unfortunately, directly observing what's inside a black hole, at least with our current understanding, is impossible.
Oh no, why not?
Remember the singularity where this exotic matter might exist? It's hidden behind the event horizon.
That point of no return?
Yes, point of no return. Once anything crosses the event horizon, including light, it can never escape.
So we can never see inside.
Not directly.
So it's like nature is playing a cosmic game of hide and seek, and we're just trying to figure out the rules.
I like that analogy.
But that's what makes science so fascinating, right?
It is.
That constant pursuit of knowledge,
Always searching for answers.
trying to uncover the universe's greatest secrets.
That's what drives us.
Exactly. So even though we can't directly observe the inside of a black hole, we can study how they affect things around them,
Yeah.
like how they interact with other objects,
Uh-huh.
the powerful jets of radiation they emit, and those gravitational waves that carry information about their collisions.
Each new piece of information brings us closer to understanding these incredible objects and their role in the universe.
It's an incredible journey of discovery, and I'm hooked. But I think it's time to switch gears a bit.
Okay.
We've talked a lot about how hard it is to find black holes
Yeah.
and the clues they leave behind.
Uh-huh.
But I'm also curious about the different kinds of black holes that are out there.
Oh, yeah. Good point.
I know there are the stellar mass black holes, the
Mhm.
ones that form when giant stars collapse.
Yeah.
But what about those supermassive ones? Those are the real heavyweights of the universe, right?
They are. And the difference in scale is just mind-boggling.
In what way?
Well, stellar mass black holes are typically a few times more massive than our sun.
Okay.
But all that mass is crammed into a space smaller than a city.
Wow, that's hard to even imagine.
It's like taking something as massive as a mountain and squeezing it down to the size of a pinhead.
That's crazy. But what about those supermassive black holes? How do they get to be millions or even billions of times the mass of our sun?
Well, that's a great question, and it's one of the big mysteries about these supermassive black holes. How do they get so huge?
Right?
The leading theory is that it happens gradually over billions of years.
Oh, wow, billions of years.
So you start with a smaller black hole, maybe a stellar mass black hole that formed from a collapsed star.
Okay.
And over time, it starts pulling in more and more stuff.
Like what kind of stuff?
Gas dust, even entire stars if they get too close.
Oh, wow.
It's like a cosmic snowball effect.
A snowball effect.
As the black hole gains more mass, its gravity gets stronger,
Yeah.
and it can pull in even more material, growing larger and larger over eons.
So it's a long, slow feast across cosmic time.
It is, and it's thought that almost every large galaxy has a supermassive black hole at its center,
Really?
including our own Milky Way.
So what do these supermassive black holes do? What's their role in how galaxies evolve?
That's a question that keeps astronomers up at night.
I bet.
But it seems like they're not just sitting there passively.
What do you mean?
They have a powerful influence on their galaxies.
Oh, wow. In what way?
Think of them like giant gravitational anchors.
Gravitational anchors.
They shape the orbits of stars and gas clouds and even influence the rate at which new stars form.
So it's not all about destruction.
Nope.
They can actually help shape and organize galaxies.
Exactly. It's this incredible interplay between the supermassive black hole and the galaxy it lives in.
So how's that work?
Well, as material falls towards the black hole, it forms a swirling disk.
Like a whirlpool?
Yeah, kind of. It's called an accretion disk.
Accretion disk.
And these accretion disks, they can get super hot,
Really hot.
and they emit enormous amounts of energy across the entire electromagnetic spectrum.
So they're shining brightly.
Oh, yeah. We're talking some serious cosmic fireworks.
Great works. I like it.
And in some cases, these active galactic nuclei, that's what we call them,
Active galactic nuclei.
They can outshine all the stars in their galaxy combined.
Wow, that is bright.
It is incredibly luminous.
So I guess that makes them easier to spot even from far away.
You got it. These active galactic nuclei are some of the brightest things in the universe.
Wow.
And they give us valuable information about how supermassive black holes grow and change over time.
It's amazing to think that something so powerful and mysterious can also play such a big role in shaping the universe we see.
It is.
It seems like every time we learn something new about black holes, they become even more fascinating and more mysterious.
They really do.
And I know our listener has been asking some really deep questions about these objects, like their connection to dark matter, the possibility of strange matter inside them, and the different ways we can find them.
And the exciting thing is we're just getting started.
Yeah,
We're only at the beginning of understanding these amazing objects.
for sure.
With new telescopes like the James Webb Space Telescope, and with scientists constantly pushing the boundaries of physics, we're going to make some groundbreaking discoveries in the years to come.
It feels like a golden age of black hole research.
It really does.
I can't wait to see what mysteries we unravel next. So for everyone listening out there, keep exploring those big questions.
Yeah, keep asking those questions.
And keep diving deep into the universe's most fascinating enigmas, because who knows what incredible discoveries are waiting for us just beyond the event horizon.
That's right. There's so much more to learn.
Until next time, keep looking up.
And keep exploring.